So this is 2018 paper. So they are asking in question 1.7, state why the chemical properties of germanium, why the chemical properties of germanium 72 and 74 are the same. So of course they are an isotope of each other, right? So what do you think? Why the chemical properties are same?
Uh, same number of same number of electrons in the valence shell.
Same number of electron in the valence shell. Yes. So means that I can say some same number of electrons, right?
Yeah.
Same number of valence electrons. Figure 2 represents a Maxwell-Boltzmann distribution curve for the particles in a sample of a gas G at a given temperature at the start of a reaction. At the start of reaction. So label both axes on the diagram. When we were discussing Maxwell-Boltzmann distribution curve,
Mhm.
so did you remember like on the x-axis what we were writing and on the y-axis what we were writing?
Think on the y-axis is the temperature, and on the x-axis like some activity or something.
It's energy of the particles
Okay, energy of the particles.
and it's the number of particles.
Oh, okay.
Give
So
a
energy
reason.
basically temperature is not the x-axis.
Sorry.
Energy as in like the temperature or something, right?
Yeah.
Okay, right.
So
Got it.
then they are asking, give a reason why the curve starts at the origin.
Uh, like the number of particles is zero or something.
The
So if
number
there
of
are no
particles are
particles, no,
okay.
if there are like no particles and there's no energy.
Mm. Yes, of course. Like when we have nothing, like we have no particles, so of course the energy of the particles is going to be zero, right? So I can
Mhm.
say that no particles, no particles means that no energy. Or you can say that uh, if we have if we don't have the number of atoms or the number of molecules or the number of particles, so there would be having no energy. So you can write this as well, okay?
Okay.
Draw on figure 2 a distribution curve for the same sample of a gas at a lower temperature. So I told you that when we have done the two graphs, like two curves at higher temperature and at the lower temperature. So at the higher temperature, the height of the curve decreases at a higher temperature and the graph shifts towards right. And at a lower temperature, the height of the curve increases, the height of the curve increases and the graph shifts towards left. So we must know what would happen at a lower temperature and we must know what would happen at a higher temperature. Okay.
Okay.
So they are asking to draw another curve at at a lower temperature. So what would I do?
Um, just at lower temperature. So
I would be drawing like that.
at lower temperature, you're gonna increase the number of particles.
No. the energy is going to decrease. The number of particles will remain the same.
Then what's like your curve like that? Like why does it
Let's
decrease?
say, let's say in this curve, we have 70% particles.
Hmm.
So in this curve, we have also the 70% particles. But the thing is that this is an activation energy. So basically, I can say that the number of particles whose energy is greater than the activation energy is going to decrease. The overall particle will remain the same. Like let's suppose it's a concept, simple. If we increase or decrease the temperature, it doesn't mean that you are going to decrease or increase the number of particles. Basically, you are going to increase or decrease the rate of reaction. It only increases or decreases the energy of activation, isn't it?
Right.
It's simple. Like we cannot decrease or increase the number of particles until or unless you are going to touch the concentration. We are not talking about the concentration, means the number of particles. We are only changing the, like, let's say, whenever we change temperature, whenever we change pressure, whenever we change volume, it doesn't mean that we are going to increase or decrease the number of particles. So
Okay.
only we have to see the activation energy. So area under the curve will remain the same. Only the only the shape of the curve changes, but area under the curve will remain the same. So
Got
means
it.
that the number of particle will remain the same. So what would happen, let's say this is an activation energy, before before drawing this curve, let's say in this area, shaded area. So I can say that in this shaded area we have 30% particles. Of course, these are the particles whose energy is greater than the activation energy. So they will be reacting with each other, of course. And when I did this one, I can say like this one. So it means that now now this is an area under the curve. So I can say area under the curve is going to decrease. Like we have 20% particles whose energy would be greater than the activation energy. So only this is going to be changed. So when the number of particles whose energy is greater than activation energy is going to decrease, so it's mean that the rate of reaction will decrease. Are you getting my point?
Yeah, got it.
A flask contains gas G. At temperature T, gas G decomposes as shown in the equation. At a temperature T, only a few particles of G have the activation energy needed to decompose. Explain why all of G will eventually decompose.
Because all of the particles reach their activation energy.
Exactly. That's why they are going to decompose themselves because they have reached their activation energy. Now they have an ability to form a product, of course. So I'm supposed to write it's of only 1 mark. Uh, particles,
Eventually reach.
particles, yeah, will have energy after collision. Because what they are saying, at a temperature T, gas G decomposes, means they are going to break down. As shown in this equation, at temperature T, only a few particles of G have the activation energy needed to decompose. Explain why all of G will eventually decompose. Of course, they will be gaining some sort of energy. Okay, they will be gaining some sort of energy. So that's the reason all of the particles of G will decompose. Why a small decrease in temperature can cause a large decrease in the rate of decomposition of gas G.
Um, A smaller fraction of the particles reach their activation energy or something like that.
So I can say that when the temperature decreases, when the temperature decreases, you can say in this graph, I have decreased the temperature. So what does it mean? Those particles which were in this area, shaded area,
Hmm.
so I can say that the number
No.
of particles whose energy is greater than the activation energy is gonna decrease. And when the number of particles whose energy is greater than the activation energy decreases, so I can say that the rate of reaction will decrease. And of course, when the rate of reaction decreases, so there would be a less number of collision between the particles per unit time. So that's why whenever you will be decreasing the temperature, whether it's a small decrease in temperature or a large decrease in temperature, but the rate of reaction will eventually decrease. Like I can say sharply decrease, I can say. So I'm supposed to write that it's of 2 marks. So number one, um, after decrease in temperature, number of particles, number of particles whose energy is greater than activation energy, whose energy is greater than activation energy decreases, decreases. So there will be less number of, there will be less number lesions per unit, per unit time. That's why rate of reaction will decrease. Then identify a reagent that could be used in a simple test tube reaction to distinguish between aqueous magnesium chloride and aqueous barium chloride. It's a very easy test.
Um, Magnesium chloride and like sulfate maybe, and observation with aqueous barium chloride, you would see like barium sulfate, so you would see white precipitate, whereas with magnesium chloride, I don't think so you would see white precipitate because magnesium is like not very reactive. So I don't know, maybe like no reaction or
Yeah,
like colorless in magnesium
yeah,
chloride.
exactly. We have two reactions to test whether you can test magnesium chloride or whether you can test barium chloride. Of course, we have to distinguish between these two. So I can say that uh, let's suppose when I would be adding, I can say um sulfuric acid. Okay, I would be adding sulfuric acid, or I should add, or I can say I should add sodium hydroxide, let's say. So when I would be adding sodium hydroxide in both solutions, in both test tubes, so in the case of magnesium chloride, I would be getting magnesium hydroxide. And in the case of barium chloride, I would be getting barium hydroxide. As we know that down the group, solubility of hydroxide increases, so barium hydroxide would be more soluble. I wouldn't see any change. Like I wouldn't see the white precipitate. But in the case of magnesium hydroxide, since magnesium hydroxide is insoluble in water, I would see the white precipitate. So in reagent, I'm writing that I would be adding NaOH. So reaction observation with aqueous magnesium chloride, I can see white PPT. I can see white PPT. And with barium chloride, I can see colorless solution. I can see colorless solution, or you can write no visible change. Because the thing is that when magnesium chloride, that is MgCl2, is reacting with sodium hydroxide, so it produces magnesium hydroxide. It produces magnesium hydroxide. So in the case of magnesium hydroxide, I can see the white precipitate since we know that the solubility of hydroxide increases down the group. So magnesium hydroxide is insoluble in water. It's insoluble in water. So that's why I can see the white precipitate. And when it would be reacting with barium chloride. So barium chloride means that barium chloride plus NaOH is going to give you barium hydroxide. Okay, so barium hydroxide is soluble in water. So I can't see any precipitate. I would see the colorless solution. Then they are asking identify a reagent that could be used in a simple test tube reaction to distinguish between aqueous potassium iodide. Potassium iodide is Ki and aqueous chloride that is KCl. State what you would observe.
Um, so the reagent would be barium. Wait, 1 second. You're gonna use a silver nitrate, that one, dilute nitric acid, and then add aqueous silver nitrate, I think, for the
Yes.
bromide and iodide, and then you're gonna get uh for the for the iodide, you're gonna get 1 second. The iodide you're gonna get yellow, and for the uh chloride you're gonna get white PPT for the chloride.
Yeah. So Ag plus I minus gives AgI, that is solid, and then Ag plus sorry, Cl minus, it gives Cl solid, that is white PPT. Well, write an equation for the reaction between solid sodium fluoride, that is NaF, and concentrated sulfuric acid, that is H2SO4. Possibly, possibly I can say that it's to give you the salt, that is sodium hydrogen sulfate, and then it's gonna give you HF. What I did in this one, I have broken down this H2SO4 into HNHSO4 minus and Na positive NF minus. So they are going to give NaHSO4 positive combines with negative NaHSO4, and rest of the ions will be combining together to give you HF. Okay.
Okay, yeah, yeah, just a normal reaction, so yeah, it makes sense. Okay. I
See this
usually
one?
get confused in the ionic equations. They're kind of weird. Okay. So NaBr, NaBr. Wait, so yeah, NaBr plus H. Wait, sulfuric acid. Sulfuric acid is H2SO4, right?
H2SO4.
So NaBr plus H2SO4.
NaBr plus H2SO4. No,
H2SO4 is sulfuric
they
acid.
are saying this is a redox reaction, right? So between solid NaB, that is NaBr, plus concentrated sulfuric acid. So since this is a
I got
redox
so.
reaction, I can say
Mhm.
H2SO4 acts as an oxidizing agent. It will oxidize NaBr, that is negative in this case. It will oxidize into, of course, oxidation is the loss of electron when bromide Br minus will lose electrons, so it's gonna give you Br2 having no charge. So this is going to be oxidized since sulfuric acid is an oxidizing agent, and then itself sulfuric acid is reduced. So I can say that in sulfuric acid the oxidation state of sulfur is plus 6. So since it's going to be reduced, it reduces itself. It reduces itself. So I can say that it will reduce from plus 6 to the lower oxidation number. So it's gonna be SO2 in which the sulfur is plus 4. I can say this is reduced. And then along with H2O is formed. Then we have to balance this equation.
What about Na?
So we have to write down, I can say, ionic equation, but we can do this one as well. Like rather than SO2, rather than like along with SO2 and Br2 or H2O, we can form Na2SO4. Of course, we have to balance this equation and we have to follow the law of conservation of mass. Mass can neither be created or not destroyed. Then we have to balance this equation. It's gonna be 2H2O. So then it would be 2H2SO4. And this is Na2SO4. This is going to be 2Na. That's it.
Okay, okay. All right.
Else you can write down an ionic equation.
Okay. Sulfuric acid would be a oxidizing agent then.
Yes.
Okay. The mark scheme also has this answer. Like, how did they write it? The mark scheme.
Yes. Do you have this?
I don't. What paper is this?
I think this is June 20, May 2018.
May 2018.
And also if you are going to write an ionic equation, and also if you are going to write an ionic equation, so we can write NaBr as Br minus, H2SO4 as H positive, and then we are going to write the products that is Br2 and SO2 and H2O. Then we have to balance it. It's going to be 2. And then I'm supposed to write 2H positive and 2 Br minus. And of
Well, yeah,
course,
there are many
H2SO4.
ways. Yeah, there are many ways, and as you said, you can also do it like a ionic equation. I think the ionic equation would be like the easiest, maybe, probably. I think so.
Yeah.
Easiest and fastest. Yeah.
But it's from group 7, like it's from halogen. So you are supposed to memorize the three equations with sulfuric acid. H2SO4 plus NaCl, H2SO4 plus NaBr, H2SO4 plus NaI. So what's the role of
Okay.
sulfuric acid? It's an oxidizing agent.
All right. Oxidizing agent. Yeah.
Oh, see this one?
Yeah. Oh, by the way, sir. I think we did the KC question, right?
Yes.
Is that not in the syllabus? Like, do I not need to know
Casey, they
that?
will be asking. You can see this one. They
But
are
I
going
didn't
to
think.
ask.
No, no.
See
Like,
this one.
is it still in the syllabus or something?
Casey or KP?
No, no. Like the KC where like let's say it's 202, right? or like 4O2. You'd take like O2 and then in the bracket, and then you'd make it power 4, right? Like that type of Kc. Do you get me?
Yeah, I'm getting you. You can see in the recent past papers.
It's there, so I need to know it.
Hmm.
Okay, all right.
You are supposed to write down the Kc basically. The same thing, product upon reactant, of course. In AS, you will be discussing Kc.
No, I thought I didn't need to know that product over reactant thing and all of that. Okay, anyways, amount in moles. So can I just do this amount in moles thing from number of particles is equal to number of
Yeah,
moles times Avogadro's?
yeah. Basically, we have to find out the number of moles, which is equal to mass over mr. Mass is 15.60 mr of NO2, that is NO2, nitrogen dioxide. And then we have to find out the moles, and then you will be doing the same thing. Like first of
Uh,
all, 2NO2, and then 2NO
we have for
plus
nitrogen
O2.
dioxide and nitrogen monoxide. I can just find either for them, and then O2 I can find from the cross multiplication, or like the
Yeah.
molar ratio.
In fact, we have to find out the equilibrium moles. In fact, we have to find out the equilibrium moles. So then we have to put the equilibrium moles in the Kc expression, right? So Kc would be equal to product upon reactant. So how do I solve this one? Um can you tell me the number of moles first?
Uh, Number of moles for nitrogen dioxide is like 2. Oh wait, you want me to calculate it? Okay, okay, wait. 1 second.
अभी ना आप नहीं आइएगा
0.33 moles for nitrogen dioxide, and as for nitrogen oxide, nitrogen oxide is 0.277.
0.277. And what about
No,
NO?
no, not for this. NO is 0.277, and nitrogen dioxide is 0.34. 0.34. How many significant figures do I give it to? Two or more?
Yeah, up to three,
Two or three?
three, up to three decimal
Three,
places.
so
0.277,
0.339.
0.339. Okay. So initial moles of NO2 is 15, oh, sorry, 0.339. Amount reacted 2x, amount produced 2x NX. Equilibrium amount of NO is going to be 0.277. Then I'm going to find out the equilibrium amount of O2 and NO2. That's going to be 0 plus 2x is equal to 0.277. So x is equal to 0.277 by 2. What's the answer?
Um, 0.1385. 139. 0.139.
0.139.
Yeah.
This is the value for x. I'm going to put x over there, and x would be the same over there. So what's the answer for 0.339 minus 2 times? Minus 2 times 0.139.
0.061.
0.061. So amount of NO2 at equilibrium is 0.061. NO at equilibrium is 0.277, and then
No,
O2
won't
is
you divide that by,
0.139.
sir, don't you divide that by 2, the
Sorry?
0.277? Don't you divide that by 2?
Uh, no, it's already given. It's already given.
Or then why did you do that for the 2NO2?
Uh, what do you mean by this 2NO2?
Like, it was also given, right? We got like
No, it was not
0.339.
given. No, no, no,
We
it
got
was not
0.3.
given. Only the equilibrium mixture of NO is given. I'm talking about equilibrium amount. I'm not talking about the initial amount, because we have to put in the Kc expressions equilibrium amount, not the initial amount. So only the one equilibrium amount is given, and with the help of the given amount, we are going to find out other one.
So for the initial amount of 2NO2, why didn't you write 0.277? Like, oh yeah, you can't write that, right? I don't think so.
So
Or
with the
like,
help of, yeah, with the help of this equilibrium amount, I can calculate the other one. So I did this.
no,
First of
can
all,
you?
I have found the x, and then
Hmm.
I have put x in the other, I can say, species.
No, like, can you explain why the initial amount? Why didn't you write like 277 there? I don't get that.
Okay, so they are saying 0.339 of mole of NO2 are heated to a constant temperature in a closed flask. Now the chapter is closed for the initial amount, isn't it?
Okay.
Okay. So I put in the initial amount, that is 0.339 of NO2. Nitrogen dioxide is NO2. Okay.
Hmm.
Then this is 0, 0, initial amount. Reaction has not started yet. The products are 0. And then the equilibrium mixture contains this much moles of NO, not NO2. So I put this one over there. Okay.
Okay.
And then this is 2x, 2x, and 2x.
Hmm.
So I have only this information, or I will be using this one, and I will be finding out this amount and this amount. So with the help of this, I have found the value of x, that is 0.139. Once I found the value of x, so I have put x over there to find out the equilibrium amount of NO2, and I have put x over there to find out the equilibrium amount of O2.
Hmm. Okay.
Yeah. Now you have to write down an expression for the equilibrium constant for this reaction that is going to be product upon reactant. So concentration of NO, NO2
Hmm.
divided by NO2.
Oh, so it's a product over reactant, right?
Yes.
It's always that,
No?
right? Or
Yeah. Yes. See this?
hmm.
They have given you the different scenario for the equilibrium.
Yeah. Uh, I don't remember this exactly. How we did this before.
Again, the same thing. Again, the same thing. It's
Product.
a more
Yeah.
easier. 2NO2 gives 2NO plus O2. What
Like, do
can
I
I
do the
do for
same
this
thing but
one?
different value?
Yeah, exactly, of
Or
course.
like, no, no. I mean, like, the KC that you found out. Is it like similar to
So
that or something?
let's see this one. Now I'm going to put a different equilibrium mixture at a different temperature contained 0.33 mole of NO2, 0.22 mole of NO, and 0.18 mole of O2 in a flask of volume 15. So what we have to do, they all are equilibrium mixtures. Only we have to write down the Kc. Of course, Kc is the concentration of product divided by the concentration of reactants. And what do you think about the concentration? It's the mole per unit volume. So mole is 0.33, sorry, 0.22 divided by 15 raised to the power 2, 0.18 divided by 15 raised to the power nothing, NO2 that is 0.33 divided by 15 raised to the power 2. Because in this question the volume is given. In rest of the question the volume is not given. So we just put the moles over there. But in fact it's a concentration. It's not a mole.
Right. Okay. Um, you want me to find the answer to this?
Okay. So basically you have to do this thing in this way when the volume is given to you. In the previous questions the volume was not given. So we were considering that that's going to be 1. But in this question this is 15 so we have to consider 15. So that's why I'm going to divide it by 15, right?
Mm, okay. Right. Wait. So the answer I'm getting is 5.3 times 10 to the power of -3, or 2/375. Basically, is the answer.
Okay. Okay. The pressure on the
What
equilibrium
about the
mixture.
sir? What
What
about the
about
unit?
it? Yeah, unit is an important. So basically unit would be mole per dm cube, then mole per dm cube,
Oh, like that, right?
then mole per
I remember
dm
that.
cube, then you have to solve it, okay?
Got it. Yeah, I remember. Okay.
ये देखो जरा, see this. The
Yep.
pressure on the equilibrium mixture is increased. Predict the effect of increase in pressure on the amount of oxygen in the equilibrium when oxygen is on the product side. Explain your answer with reference to Lee Chatelier principle.
So, sir, I think when you increase the pressure, yeah, the equilibrium goes to the side with the fewer moles, I think.
Yep.
So, in this case, if they increase the pressure, it's gonna go to the left hand side. So, more nitrogen dioxide will be made, if I'm not wrong.
Mm,
Because there are two
yes.
moles on the left hand side and three on the right. That's why.
Basically, they have specified that you have to only see the number of moles of oxygen. So we have to discuss only oxygen, not the nitrogen dioxide.
What?
So I can say that, see this one, see this the question, what they are saying. You have to focus on oxygen.
Yeah, so I can say that
Yeah.
the conclusion here would basically be that the amount of oxygen decreases.
Decreases, right?
Yeah,
And then
because
you
it
have to
shifts
explain
towards.
it. So I can say that it's of 3 marks. So
You can use the molar
equilibrium
ratios.
moves
Yeah.
to decrease pressure. So more moles on the right hand side, that is 3. 2 plus 1, 3. To the reactant that okay, then see this one.
Okay. Um, draw the shape of the PCl and include any. Okay, PCl molecule is shape. Okay.
So of course
Um,
you have to determine the number of lone pairs and bond pairs, right? How many lone pairs and how many
no,
bond
in
pairs
this,
are there?
uh,
Draw the shape they are saying. Okay.
so do I have to draw it like with the outer shell electrons or something like that? Or what?
It's pyramid shape
Right, and there's a lone pair as well. Yeah, right.
because it has 3 bond pairs and 1 lone pair. So the bond angle would be 107.
Right. Okay. Right.
What about SF3 minus?
SF3 minus. So that means that it has one extra electron. So I think coordinative dative. I mean, is it that like coordinate or dative coordinate dative coordinate covalent bonding? Is it that by any chance or no?
Uh, you're
Because it's
talking about
DNA.
SF3
Uh,
minus, right? So
Yeah.
in which group SF3 is present? Like I'm
Sulfur
talking about
is
sulfur.
sulfur is in group 6.
So it has three fluorine atoms like a sulfur, then it has F, then it has F, then it has F, and along with this one, it has used its three electrons with fluorine. So rest of the electrons remaining would be, how can I say, one, two, three, four, because it's going to have six electrons already. And of course, it has a negative charge as well. So I have to write down one more electron. So I can say it would be having I can say that it would be having three bond pairs and two lone pairs. Okay, three bond pairs and two lone pairs. Okay,
Right.
yeah.
Right.
Which
Yeah. Okay.
substance does not have hydrogen bonding between its molecule? So if you remember, what was the hydrogen bonding? It's the bond between hydrogen and phone, highly electronegative elements. That was three: fluorine, oxygen, and then nitrogen.
Yeah. So the answer to this would be um the
Does not have
wait,
hydrogen bond. So it would be having hydrogen bond. It would be having hydrogen bond. It would be
I
having
don't.
hydrogen bond. It's an alcohol, right? So of
Yep. The
course the
OH
answer is
bond there
this
would
one.
be. Yeah. Because hydrogen would be only bonded with carbon.
Exactly.
Okay. This one isn't very difficult. To do this, I have to use a PV equals to nRT, and yeah, I will have to. It's already in meter cube, so I have to just convert the kilopascal to Pascal and degree Celsius to Kelvin, and that would be my answer. Just have to
Yeah.
do that.
Okay.
But they're asking for the molecular mass, right? So I will do mass over molar mass.
MR. Yeah, exactly.
Not MR, sorry. I will do number of moles times MR.
Yeah, exactly. They're asking molecular mass. That's why.
Wait,
It's
no,
of
one
four
second.
marks. So it's of
Yeah,
four
yeah.
marks. So first
Right.
of all, we have to, you can solve it directly as well, right? I can say that when PV equals nRT and N is the number of moles, so mass over MR into RT, that will be PV. So MR is equal to, it's the objective, it's the unknown. So it would be MRT over PV. So you have to put all the values in this equation, then you will be getting an MR finally.
Right. Yeah, like that. Okay. Got it.
Okay. See this?
Um. Okay, so I need to get the relative molecular mass of the previous question, which was uh 1 second. Okay, wait. I need to solve the question. Can I just, or instead of doing that, I can just use 111. Yeah, so can also do that.
Uh, why is the oxide of a group 6 element, right? Use your answer to question 6.1. So to suggest the identity of Y, if you are okay. So I'm saying that the relative molecular mass for the question was 80. Okay. So if the mass is 80, if the answer is 80, and they are saying that this is the group 6 oxide, so group 6 means that it's going to be aluminium, silicon, phosphorus, and then
Selenium, I think.
sulfur. then sulfur, and then we have like, then you can move like down.
Selenium would be the answer, I think.
So, so first of all, what would be the formula for the group 6 oxide?
Uh, oh wait, it's an oxide. Oh, okay.
Yeah,
SO2, SO2, uh,
SO2. So, so is the
sulfur.
answer, is the molecular mass is matching with SO2? If yes, so it's gonna be correct, and if not, then you have to think about the other one, right?
It's 64, so it's not correct. I don't think so.
It's 64. Yeah, so it's not correct. So I'm supposed to say that it's gonna be SO3, isn't it? 48 plus 32.
Oh, okay. Right, yeah. Yeah, that's exactly it, yeah.
Yeah, exactly.
Okay.
Define standard enthalpy, change of formation.
Sir, you can stop here because I have another class. So, yeah.
Yeah, okay.
All right.
Thank you.
Okay, thank you.